During the past lessons, we have learned about the unit circle and graphing of sine and cosine functions. These lessons will help you a lot in our new topic, graphing of other trigonometric functions which are cosecant, secant, tangent, and its co-function identity cotangent. Let's get started! First of all, you need to know the basics. Make sure that you have your matrix. Tangent function is odd. Tangent negative x is equal to negative tangent x. The graph of y is equal to tangent x is symmetric with respect to the origin. Tangent x is equal to sine x over cosine x. Tangent is undefined for values at which cosine x is equal to 0. Two such values are x is equal to positive negative pi over 2. The period of the tangent function is pi. Vertical asymptotes also occur when x is equal to pi over 2 plus n pi, where n is an integer. Asymptote is a line that continually approaches a given curve but does not meet it at any finite distance. The domain of the tangent function is the set of all real numbers other than x is equal to pi over 2 plus n pi, and the range is a set of all real numbers. Sketching the graph of y is equal to a tangent bx minus c is similar to sketching the graph of y is equal to a sine bx minus c, in that you locate key points that identify the intercepts and asymptotes. The graph of the cotangent function is similar to the graph of the tangent function. It also has a period of pi. However, from the identity y is equal to cotangent x is equal to cosine x over sine x, you can see that the cotangent function has vertical asymptotes when sine x is 0, which occurs at x is equal to n pi, where n is an integer. The graphs of the two remaining trigonometric functions can be obtained from the graphs of the sine and cosine functions using the reciprocal identities cosecant x is equal to 1 over sine x and secant x is equal to 1 over cosine x. For instance, at a given value of x, the y-coordinate of secant x is the reciprocal of the y-coordinate of cosine x. Of course, when cosine x is equal to 0, the reciprocal does not exist. Near such values of x, the behavior of the secant function is similar to that of the tangent function. In other words, the graphs of tangent x is equal to sine x over cosine x and secant x is equal to 1 over cosine x have vertical asymptotes at x is equal to pi over 2 plus n pi, where n is an integer, and the cosine is 0 at these x values. Similarly, cotangent x is equal to cosine x over sine x and cosecant x is equal to 1 over sine x have vertical asymptotes where sine x is equal to 0, that is, at x is equal to n pi. In order to sketch a graph of a secant or cosecant function, you should first make a sketch of its reciprocal function. For instance, to sketch the graph of y is equal to cosecant x, first sketch the graph of y is equal to sine x. Then take reciprocals of the y-coordinates to obtain points on the graph of y is equal to cosecant x. Now that you know the basics, let's try some examples.
Graph of tangent function. Y is equal to 4 tangent pi x. Before we proceed to graphing, let us first identify its properties. Fake amplitude. As I mentioned earlier, there are no amplitudes in tangent, cotangent, cosecant, and secant. However, we will use fake amplitude for better illustration and understanding. In this case, 4 would be the amplitude. In getting the period of a tangent, we use pi over b instead of 2 pi over b, since tangent has pi period, so pi over pi is equals to 1. Since there are no phase shifts and vertical shifts in this problem, we'll leave it with 0. To get the intervals, we count by 1/4 multiplied to the period. So 1 times 1/4 is 1/4. 1/4 is the interval. And these will be our guidelines in making our t-table. I prefer using t-table since it is easier to plot the points in the graph, especially when you have your matrix. Moving on. We start with the phase shift and counting by quarter of a period. We take that x value, which is 0, then equate it in the equation. 0 times pi is 0. Using our matrix, we should be able to know that the tangent of 0 is 0. Then we multiply that 0 to the amplitude, which is 4. So 0 times 4 is again 0. Then the value of y is 0.
Trivia!
We should always remember that in getting the value of y in t-table, we should first take of our x value, equate it in the equation, find the value of that tangent in your matrix, and then multiply it to the amplitude since this problem doesn't have phase shift and vertical shift. We are now in our final step, graphing the tangent function. So let's start by plotting the intervals of the x-axis from our t-table. Then draw the y-axis vertical to where 0 is. Then label our fake amplitude in accordance to the y-axis. At 0, we have 0. At 1/4, we have 4. At 2/4 or 1/2, we have an undefined value, so that's gonna be a vertical asymptote. At 8/4, we have -4, and at 4/4 or 1, we got 0 again. Connect the points wherein the graph is ascending to infinity beside the asymptote without touching it.
Graph of the cotangent function. Y is equal to 2 cotangent x plus pi over 4 minus 1. Our amplitude would be 2. Period is pi over 1, so pi. Phase shift is negative pi over 4 since the original equation is bx minus c. Vertical shift would be negative 1. And again, to get the interval, multiply period by quarters, so the interval is pi over 4. Set up the t-table. Start with the phase shift, then count by quarter of the period again. Equate negative pi over 4 in x plus pi over 4. So negative pi over 4 plus pi over 4 is equals to 0. Cotangent 0 has the value undefined in our matrix, then y is undefined. Following the steps used in tangent, we equate, find the value in our matrix, multiply amplitude, and since we have our vertical shift in this problem, we add it in the end. Plot the intervals in the x-axis, fake amplitude in our y-axis, and then we proceed to plotting points of our cotangent function. At negative pi over 4, we have a vertical asymptote. At 0, we have 1, and so on. Connect the lines, and we're done with the tangent function.
Graph of cosecant function. Y is equal to -2 cosecant x plus pi over 4 plus 1. Fake amplitude is the absolute value of A, so 2. We use the equation 2 pi over b since cosecant and secant are the reciprocal functions of sine and cosine. 2 pi over 1 is 2 pi. Phase shift is negative pi over 4. Vertical shift is positive 1. The interval is 2 pi times 1/4, which is 2 pi over 4. Note, although it can also be reduced as pi over 2, we would like to make sure that it has the same denominator with a phase shift for easier plotting. Set up the t-table. Start with a phase shift, then count by quarter of the period again. Since cosecant is the reciprocal function of sine, we need to graph sine first. We will replace cosecant with sine in the equation, then proceed to equating. Equate negative pi over 4 in x plus pi over 4, so negative pi over 4 plus pi over 4 is equals to 0. Sine 0 is 0 in our matrix. 0 times negative 2 is still 0. Then 0 plus 1 is 1. Therefore, y is equals to 1. And by repeating the same steps, reusing graphing tangent and cotangent, we will be able to complete our t-table. Graph the x-axis, and since we have no 0 in our x-axis intervals, we put the y-axis between negative pi over 4 and pi over 4. Plot the points, and I've added 3 more points to show you better how the graph works. The yellow broken line is the sine function. The pink broken lines are the asymptotes, and the blue ones are our cosecant function graph.
Graph of the secant function. Y is equal to negative 4 secant x plus 2 pi over 4 plus 2. Fake amplitude is the absolute value of A, so the amplitude is 4. The period is pi. Phase shift is negative 2 pi over 4. Vertical shift is positive 2. The interval is pi times 1/4, which is pi over 4. Set up the t-table. Start with the phase shift, then count by quarter of the period again. Since secant is the reciprocal function of cosine, we need to graph cosine first. We will replace secant with cosine in the equation, then proceed to equating. The first y value is negative 2, and by repeating the same steps we used in graphing tangent, cotangent, and cosecant, we will be able to complete our t-table. Graph the x-axis and put the y-axis vertically between to where 0 is. Plot the points and connect the dots. The yellow broken line is the cosine function, the pink broken lines are the asymptotes, and the blue ones are our cosecant function graph. Did you learn a lot today? Now hit the subscribe button and do your homework. Thank you for watching!